Welcome, this is the second question in Edexcel's C4 January 2006 past paper. Now, it's got a few parts to this question. The first part, I've drawn this table, obviously, because the kind of guy I've given you the information, so you'd have to look through the actual paper online. You have to actually type it in, or even print it off. Now, what I've done here for you is obviously drawn it off on whatever it is, this magical device here, the bits of information that you're given in the paper. Now, we are told the equation of this curve, we're not shown it, it's not drawn for us. Usually they draw the curve to give us some kind of indication of what it looks like, but say on this day they decided to save themselves a bit of printing costs, or the guy just couldn't be bothered drawing it, probably the latter. Anyway, so essentially what we're given here is this table with a few values in, and we're asked to fill in the remaining values. Now, this is one of the easiest parts of the question, or any question you will ever see on C4. Partly because it's a C2 topic and really nothing's changed apart from the actual equations. But as I said, the key thing with this is remember sec x is 1 over cos x, and if you can't remember that, what are you doing in a maths exam? Although I may just insulted quite a few, but the key thing with these is look at the third letter and that will tell you what it is. So sec, C being the third letter, it's 1 over cos. So x, you just obviously because whenever you see pi, it's in radians, and in fact whenever it asks you a question and it doesn't specify degrees, you always assume radians. I mean, generally it will tell you, but the key gives away are the words degrees, or it says radians, or it gives it in terms of pi. Now, obviously we're talking in radians here because you can see pi, so it's just a case of subbing in your numbers. So the first one is obviously 1 over cos pi on 16, and the key thing with this is to what degree of accuracy do you give it. Now, many of you will look at well, the key thing with this is look at the values they give you in the table and give it to the same degree of accuracy. Now, the first one, where x is 0, y is 1. Now, they didn't put y is 1.0000 because that'd be pointless. But there's another, so we can't go off that value alone because maybe they wanted it to 6 technical figures, but that is specifically 1. Now, what we've got, x is 3 pi and 16. That doesn't cancel down, so I don't think they've just gone lazy. I tried that myself. They've given it to 5 decimal places and 6 significant figures if you want to, whichever way you want to look at it. Obviously it's not going to be more than 1 or more than 9, obviously in this case, so don't worry about that. But anyway, they've given it to 4 decimal places, 5, I keep saying 4. They've given it to 5 decimal places, so you should give it to 5 decimal places as well. I think they knock a mark off if you don't in the mark scheme. So it's just a case of subbing the rest of the numbers in into your calculator. There's not much more I can talk through on that, so I'm just going to simply write the numbers in and try and do a bit of talking as well, so it didn't seem too boring watching the back of my head, as exciting as that is. So the first one is 1.0 1959. The next one is where x is pi on 8. It's 1.08239. Okay. Obviously, it's given us what y is when x is 3 pi on 16. The last one is where x is pi on 4, and when you put pi on 4 into 1 over cos x, x being pi on 4, you get a value of y to be 1.41421. Okay. Right, now the next part asks us, where it gives us the formula where we're asked to integrate sec x where the top limit is pi on 4 and the bottom limit is 0, obviously with respect to x. Now, some of you may go, oh, we'll look in the formula book. Well, tan squared x differentiates to get sec x, but You can't really do the integral. Anyway, it's asked just to use the data we've been provided with. So obviously it's going to ask to use the trapezium rule, and oh look, I've done the trapezium rule on the board for you. What a coincidence. Or maybe I've actually thought about helping you now. I don't know, whichever one. Anyway, so it's just a case of subbing in your numbers. Now the only thing that may confuse some of you on this is, well obviously we've got h over 2, but what is h? Now again, I've written what h is, how good am I? Well, I've done h is b take a over n. Now what the hell does that mean? Obviously you should know, but if you don't, I'll just tell you again because I had to look it up. B is the top limit, A is the bottom limit, and N is the number of strips. Now, B and A, obvious. B is pi and 4, A is 0. So you can just write pi and 4 over N. However, what is N? Now, N is not the amount of X values you see here, because that would be 5. I did not have to count that at all. Now, the reason it's 4, not 5, is because, say, I don't know, I'm just going to draw a quick sketch, just give you a bit of an idea. So, obviously it's not going to look anything like this, but say it did something like that. Obviously that's an X cube graph, so it wouldn't. But this first line X0, that's not a strip, that's just saying where it starts. And similarly, this line at the end, pi and 4, that's not the last strip, that's just where it ends. So it's actually 4 strips. Sorry, it's not the line at the start because that's where it starts. Okay, so it's 4 strips, because if you were to draw out the 5 lines, then you would end up with 4 areas in between them. Okay. Alright, so hopefully that kind of summed it up in your head, because I had a bit of trouble when I was like, okay, well what's N then if it doesn't tell you? It generally should, but just in this case it hasn't. Okay. Right. There are other ways of working the area out, such as the Simpson's rule, which is very similar. But anyway, that's AQA, so shut up. So the first thing you would do is work out what H is. Now it's just, excuse me, H is just pi and 4 divided by 4, which obviously gets you pi and 16. Okay, so it's just pi and 16 over 2, so obviously it's pi and 32. Okay. Now, just to, as I said, I'm assuming you know this anyway, but y0 is the very first one, yn is the very last y value, and the rest are all times by 2, okay? Before being times by pi and 32, obviously. So it's just a case of subbing. I think you get given this formula anyway. I assume you do, it's simple enough anyway. So the first value is 1, the last value is 1.4. 1421. Now you could just simply do that to 2.41421 straight away, but it's nice to show where you're getting the formula from. Plus 2 times the remaining value, y values, which is where x is pi and 16, so it's 1.019959 plus 1.08239 plus 1.20269. Okay, and then it's just a case of subbing that into your calculator and working out an eventual answer. And obviously that gives you the area. Now it's not specific, because remember we went into a bit of detail in C2 why it doesn't match up perfectly, and that applies here. Same kind of thing, it's the exact same thing for C4. The only difference is we're using a different formula. Okay. So when you sub that in your calculator, you should get an answer of, I'm just getting it from the math scheme because I don't want to say a wrong one, pi on 32 times 9.02355, which gets you an answer of 0.8859. 0.8859. Now what I do, it doesn't say in the mark scheme, I don't think, but obviously because this is an area, it's not a volume, it's just a simple area, so it's squared unit. So you just put units and then put a little there, okay? So it's just squared units, 0.8859 squared units, okay? Now, the next question says, find the, now we know the proper area is actually worked out by, you know, converting sec x into something, and then you could look in the formula sheet if you wanted to and work out what it actually is through the proper methods of normal integration. But we're told the official area, the proper area, is ln of 1 plus root 2. So just using the proper integration method, okay? So that's the official area, and this is the area that we worked out. Now, predictably, I'm moving down. I'm sat on the chair because otherwise my big head will be in the way, and also I want to sit down. I'm sure I won't get shot for that. Anyway, back to this actual maths. So what I'm saying is, this is the area we worked out using the trapezium rule, which you can see is a lot easier than trying to convert that into whatever and looking in the formula book. Bit of a waste of time. And this is the official area that someone's actually gone and worked out. Okay, so they want us to find the percentage error in the area. Now, the key thing is these two are going to be very close. Okay, so percentage error. So it's obviously any percentage question is obviously going to be times by 100, and it's the error. So the percentage error is the error in the area over the original proper area times 100. Sorry, my writing is terrible when I've sat down. So it's the error over the original area or the proper area times 100. Now, what we have to ask ourselves, oh, well, what is the area? The error in the area. Well, it's going to be the difference between these two. And now, which way around you do that is going to give you the right or the wrong answer, obviously. Now, I think it's quite self-explanatory, but I'll go through it anyway. I'm not very good at it. I probably insulted you about 3 or 4 times. But don't be worried, I went through this method, and that's the only reason why I'm picking it up. Okay, so if you did 0.8859 take away, you know, the ln of 1 plus root 2, or if you did ln of 1 plus root 2 take away the 0.8859, one of them way around, which one of them methods is going to give you a negative area. And obviously, you know, you just have to turn that positive because, you know, you can't have a negative percentage error sort of thing. Well, it should be sprouting up at you anyway. So, if you were to do the ln of 1 plus root 2, you would get 0.88137, okay? So, that is 0.88137. That's the official ln of 1 plus root 2. That's the official area, okay? So that's the original area, and now that's what we put on the bottom. And as you can clearly see, the area that we found out is overestimating, because if you actually think of what this sec x graph is, it's 1 over the cos graph, and the cos graph looks something like that. So, you know, hopefully it's self-explanatory. That because it's on a curve, it's on a point bit, we're going to be overestimating the area. As I said, if you didn't get that, it doesn't really matter. Just trying to give you a bit of background to why we do, because obviously we're not going to have a negative percentage area. Alright, right, so what we do therefore is we take 0. So I'll just do this for you. I tried to give you a bit of background there, top the output. I've probably confused you some more. So it's 0.8859. Take the ln of 1 plus root 2 over the ln of 1 plus root 2 times 100, which should get you a percentage error of 0.51%. Okay, now it's going to be very small because we know the ln of 1 plus root 2 and 0.8859 are very close. So even though it looks like a ridiculously small percentage error, that just shows how good the trapezium rule is at estimating an area. Now, as I said, the Simpsons rule is something to do in AQA if you want to have a look at it. Obviously you're more than welcome to, I'm not going to stop you. It's very similar to that, but it gives a bit more of a, obviously your percentage area will be even less error. Okay, I think that's the end for question 2. Double check. Yeah, that's the end for question 2. So that's a nice 7 marks there. The only thing you may have slipped up on is you may have done the ln of 1 plus root 2 take away 0.8859 and done that over 0.8859, which would have given you a negative percentage error, which is obviously wrong because you can't have a negative percentage error. Well, technically it could, you say, if it's underestimating, but really, in proper terms, we want it to be a positive thing. Now, you can't just times it by -1 because you got a negative answer. You can't just change the answer. So that's the way you know you've done it wrong. That's just kind of a small tip, really. The rest of it you should have known from C2. Now, this could have easily been a C2 question if they'd have told you sec x is 1 over cos x. But, you know, I'm not complaining they put a C2 topic in, not at all. It's quite a nice 7 marks. 7 marks you really should be getting, which is almost a tenth of the paper, just to put it in perspective. Okay, so thanks for watching. Hopefully I've not waffled on too much. As I said, the last part of the question may have been the trickiest, but really should have been quite self-explanatory. So anyway, we'll see you in question 3 if you're sticking around.